Hello and welcome to yet another video of Cornerstones of Math, and welcome to yet another South Korean College Scholastic Ability Test video, which is the test that high school seniors take to apply for the college. Today we are going to take a look at the following problem, which looks rather complicated, but if you are well armed with various calculus knowledge, this problem is really easy to solve. So there exist two solids of revolution, A and B, which are obtained by rotating curves y equals 3x squared and y equals x squared, where y is both from 0 to 10, respectively, about the y-axis. So we rotate like this. Initially, the water is only filled within A, and then through a small hole near the origin O, the water begins to flow into the space surrounded by the exterior of A and the interior of B. If U and V denote the heights of waters inside and outside of A respectively, what is the value of dV over du at the moment when V becomes 1/2 of U? Alright, as I said, this problem is quite easy if you have strong fundamentals in calculus and also if you can quickly come up with a suitable relation. So what is the key relation in this problem setting? Well, obviously it has to do with the amount of water. Let us denote the volume of water inside the inner container as V sub in and the volume of water between two containers as V sub out. Then, if we add these two volumes, this gives the total amount of water, V total, which is constant. That is, the total amount of water does not change over time. And as for the individual volumes inside and outside the inner container, we use the following formula for the volume of the solid of revolution. The volume of the solid of revolution obtained by rotating the region between the curve and the y-axis from y equals a to y equals b is given as pi times integral x squared dy from a to b, which comes from the fact that the cross-sectional area is given as pi x squared. From these two equations, the inner parabola gives x squared equals y over 3, and the outer parabola gives x squared equals y. Therefore, V in can be obtained by pi times integral y over 3 dy, where y is from 0 to u. And as for V out, we have to rotate the region that is in between two parabolas. So we have pi times integral, now from 0 to v, the outer parabola, which is x squared equals y, minus the inner parabola, which is x squared equals y over 3. And this equals the total volume of water, which is the value of this integral, by the way. But we are not going to use this value at all, so you can just ignore it. Here, let's divide by pi and write the equation as integral from 0 to u, y over 3 dy, plus the integral from 0 to v, 2y over 3 dy equals v total divided by pi. So we have this, and we want to obtain the value of the derivative dv over du. One might think about introducing a time variable since the individual terms change with respect to time, but the thing is, we can totally solve this problem without introducing the time variable. Since the problem wants us to find the value of dv over du, we can just straight up differentiate the obtained equation with respect to variable u. When doing so, we use several important properties. The first one is often called as the fundamental theorem of the calculus, but the first part, which can be interpreted as the formula for the derivative of the function defined as a definite integral with variable x in the upper bound. So by this property, the derivative of the first term is simply u over 3. But the second term has v at the upper bound of the integral. Therefore, as for this part, we have to use another property, which is the famous chain rule. In the context of this problem, this rule means that if we want to differentiate something with respect to variable u, we can do so by first differentiating with respect to some other variable v, then we differentiate v with respect to u. So if we are to differentiate the second term with respect to u, first we differentiate with respect to v, which gives 2v over 3. Then we differentiate v with respect to u. And as for the right hand side, since this v total divided by pi is constant, the derivative simply gives 0. The problem wants us to deal with the moment when v equals 1/2 times u. So substituting this, we obtain u over 3, then the second term becomes u over 3 times dv over du equals 0, which means that at this moment, dv over du has the value of -1. Therefore, if we look at the choices, the correct choice is 2. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.